Hello and welcome to yet another video of Cornerstones of Math. Today we will solve a simple counting problem regarding the number of functions. The problem says, consider a set A which has elements 1, 2, 3, and 4 and a function f from A to A. Find the total number of functions f satisfying each of the following conditions. For problem A, fn is greater than or equal to n for all elements of A. And for problem B, fn is greater than or equal to n, now only for n equals 1, 2, 3. And for problem C, fn is greater than or equal to n for n equals 1, 2, 3, and f is also bijective. Alright, first things first, when we say a function from set x to set y, it means an assignment of an element y to each element of x, where x is called domain and y is called codomain. So this is a function. But this assignment is not a function because now there are two elements of y that are associated with this element 3 from x. And this assignment is also not a function because now the element 3 from x is not associated with any elements of y. So now we have reviewed our definition of functions, let's get on to the problem. The condition to the first problem is that fn must be greater than or equal to n for all four elements of A. And this is quite easy if we think about possible values for each output, f1, f2, f3, and f4. First, f1 can be either 1, 2, 3, or 4, so we have 4 possible candidates for f1. Next, f2 can be either 2, 3, or 4, so we have 3 possible candidates for f2. And obviously, f3 can be either 3 or 4, so there are 2 possible values. And f4 can be only 4, so there is only 1 possible value. Therefore, total number of possible functions is 4 times 3 times 2 times 1, which is 24. For the second problem, now this inequality condition only has to be satisfied for n equals 1, 2, and 3. Therefore, for f1, f2, and f3, we do the same thing. f1 can be either 1, 2, 3, or 4, so 4 possible values. f2 can be either 2, 3, or 4, so 3 possible values. f3 can be either 3 or 4, so 2 possible values. And for f4, notice that element 4 is not under any constraint. So f4 can be any element of A, which is one of 1, 2, 3, and 4. So we have 4 possible values for f4. Therefore, total number of possible functions is 4 times 3 times 2 times 4, which is 96. Now the third problem, which this part is the same with previous problem, but we have an additional condition that f must be bijective. Here, a function is said to be bijective, also known as one-to-one correspondence, when each element of either set is paired with exactly one element of the other set. In this set of rules, it is beneficial if we start with f3. Here, due to the inequality condition, f3 can be either 3 or 4, so we have 2 possible cases. Now f2. Under the inequality condition, f2 can be one of 2, 3, and 4, but excluding the value corresponding to f3 due to the bijective condition. Therefore, there are 2 possible cases for f2. Similarly, f1 can be one of 1, 2, 3, and 4, excluding the values corresponding to f2 and f3. Therefore, there are 2 possible cases for f1. Finally, in order to satisfy the bijective condition, f4 corresponds to one remaining element of A. Therefore, total number of possible functions is 2 times 2 times 2 times 1, which is 8. And that was all for today's video. Thank you for watching, and I will see you in another video.